In the last video, we went over this example, nearsightedness among students. We went over part A and B, and in part B, where we left off, we went through different ways of calculating a probability. Part B was asking for the probability that exactly 9 students out of the 20 are nearsighted, and so we did different ways for that calculation. It ended up being 0.1597. And before going on to part C, I wanted to put that in context, the 0.1597. Here's a probability distribution for all possible outcomes for the sample of 20 students. The X represents the number of students who are nearsighted, and here are the probabilities. And so, for example, the one that we just did, P of 9, the probability that exactly 9 of 20 students are nearsighted, that would be right here on that distribution table, 0.1597. And we could do that same process to get all these other ones for when X is 0 or 1 or 2. That would give us all of these other probabilities. If you plot this table onto a histogram where you have probability on the y-axis and the number of students who are nearsighted on the x-axis, this would be what it looks like. Here's the histogram, and it kind of has that bell shape to it. Not quite a bell shape, but it's close to being a bell-shaped curve for the histogram. So that's just some context to it. But we'll go to the rest of the problem. So in part C of the same problem, it says, what's the probability that fewer than 6 of the 12 students are nearsighted? So ultimately, we're trying to find this, the probability that X is less than 6. And like before, there are different ways of doing this calculation. But unlike the last question, we'll have to use some different methods. In the last question, it asked for the probability that exactly 9 students are nearsighted. But this question is asking, what's the probability that fewer than, in this case 6, fewer than 6 students are nearsighted. When you're dealing with the range of outcomes, for example, if it says fewer than, more than, at least, at most, then you'll use these methods instead. They'll be slightly different. So you can still use a formula. It's the same formula. And we'll want to note that the probability that X is less than 6, that just means that X could be 0, 1, 2, 3, 4, or 5. And to get that, you could just find the probability of 0 plus the probability of 1 plus the probability of 2 plus probability 3 plus probability 4 plus the probability of 5. And so you would use the formula for each of these individual probabilities, plug in those numbers. So here's the probability that 0, this right here is the probability that 0 are nearsighted. This right here is the probability that 1 would be nearsighted. Here's the probability that 2 would be nearsighted. I didn't show them all, but skip a few, and here's the last one, the probability that all 5 would be nearsighted. You use that formula for each one, you add them all up, and it comes out to 0.1256. Another way to calculate this is to use a graphing calculator. And again, because this question is asking for a range of outcomes, it says fewer than 6, you'll want to use a different function called BCD on the Casio, or Binomial CDF on the TI-83 or 84. And these two functions, BCD and Binomial CDF, they're programmed to calculate this, the probability that x is less than some number, less than or equal to some number. And that means that before you use your calculator, you'll have to think about that, and you might have to rewrite your problem. We're trying to find the probability that x is less than 6. And x being less than 6, that means that x could be 1, 2, 3, 4, or 5, which is the same as writing it this way. The probability that x is less than or equal to 5. So these two things, x less than 6 and x less than or equal to 5, they mean the same thing, but it's important to write it this way because the calculator is going to only understand when you write it in this form. So once you have it in that form, on the Casio calculator, here are the steps, but keep in mind that for the x, you're putting in 5. You're using whatever number this came out to be when you rewrote it in that way. So this has to be a 5. The n is still 20, the p is still 0.40. Same with the TI-83 and 84. The x is 5. And so when you put it in, with the x being 5, then you'll also get the same answer that we got before, 0.1256. And the third way of doing it is to use a table. This is a different table because we're dealing with a range of outcomes. So that means that for this as well, we'll have to do a different way of using the tables. This is table 4 in the book. It's called the cumulative binomial probability table. And the table is also designed to calculate this same thing. It's still making the same assumption as the calculator. And that means that before you use the table, you'll have to rewrite your probability in that same way. So same thing as before. X is less than 6 is the same as saying x is less than or equal to 5. And what we would do is go to table 4, and on the table look for n equals 20, but look for an x of 5 and a p of 0.40. So I'll go ahead and look at that table. Here's table 3, but table 4 is here. I'll go to an n of 20. The x that we want to use is 5, and then the p is still 0.40. So like this. See where they line up, and it looks like it matches what we got with the other ways, 0.1256. One other note is that, just to put this in context, it was asking what's the probability of it being fewer than 6. And so in this probability distribution, that would be the same as adding these probabilities from 5, 4, 3, 2, 1, and 0. If you add these ones, you should get that same answer of 0.1256. Here's part D of this same problem. What's the probability that more than 8 of 20 students are nearsighted? So we want to find this probability that x is more than 8. Here again, we could use a formula. we'll just make a note that x is greater than 8. That means that x could be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, or 20. I skipped a few here. And that means that one way to do it is to find the probabilities for each one individually and then add them all up. So I wrote down what that would look like partly here. I skipped some in between because that would be a lot to write down. But for example, this is the probability that 9 would have nearsightedness. Here's the probability that 10 would have nearsightedness. And you just do that, add them all up, and it should come out to about 0.4044. For this one, you can also use a calculator. And because we're dealing with a range of outcomes more than 8, here again you'll use BCD or Binomial CDF on the calculators. And also, it's good to remember that these functions assume that you want to calculate this. The probability of x is less than some number. And that means that for these ones, you'll need to first rewrite the problem. In this case, we're trying to find the probability that x is more than 8. Remember that that means that x could be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We want to somehow make it turn around so that it's in the form of less than or equal to. And the way to do that is to use the complement rule. This probability is equal to 1 minus its complement. And the complement of 9, 10, 11, 12, all the way to 20 are all the numbers below. 0, 1, 2, 3, 4, 5, 6, 7, 8. So we'll do 1 minus that complement. And that complement can be written as x is less than or equal to 8. So this right here is the complement. And keep in mind that when you do 1 minus a complement, you get another probability. So with this in mind, we'll use the calculator to find the probability that x is less than or equal to 8. And then once we find that, we can do 1 minus that result to get the probability that we're looking for. So here again are the directions for the calculators, Casio and TI-84. When you do that, the probability that x is less than or equal to 8 comes out to 0.5956. So that means that the one that we want is going to be 1 minus 0.5956, which comes out to 0.4044. And then the third way is that you could use a table. It's that same cumulative binomial probability table. And so, but like before, remember that table, it's designed so that it's doing this calculation, that x is less than or equal to a number. And that means that you'll still have to do that same rewriting of the problem. And in the same way as we just did, where you have to do 1 minus the complement. And so on the table, you would look up the values to give you this probability, 20, 8, and 40, 0.40. When you look that up, you'll get 0.5956. In fact, we'll take a look at that over here. So for 8 and 0.40, there's the 0.5956. And then to find the problem that we're looking for, we'll do 1 minus the complement and get that same answer.